if the polynomial p of x divided by x minus c, then the remainder is the value p of c. Prove p of x is equal to x minus c times the quotient q of x plus r. And let's say we evaluate p of c to see what we get. So p of c is equal to c minus c times q of c plus r. And this is 0 times q of c plus r. This equal r. So this telling us that p of c is equal r, the remainder. So again, the remainder of the quotient is p of c. Factor theorem. C is a 0 of p if and only if x minus c is the factor of p of x. So let's prove that. So if p of x factor, so if p of x factor as p of x equal to x minus c times q of x, then the value p of c is equal to c minus c times q of c, and this is equal to 0. So again, c is a 0 to p. Now in the other way, well, if p of c equal to 0, then by the remainder theorem, we have p of x equal to x minus c times q of x plus 0. Okay, and this is equal to x minus c times q of x. This means x minus c is a factor of p of x. Next one. Show that the given value of c are the 0 to p of x and find all other 0 of p of x. Okay. Show that all the given value of c are 0 to p of x and find all other 0 to p of x. Well, it would be helpful if we know what is the value of c. Hang on 1 second. C here is equal to -2 and c equal 3. So show that the given value of c are 0 to p of x. So first of all, we will check p of -2. And when we plug it into this p of x, we better get 0. It's equal to 3 times -2 to the 4 minus 8 times -2 to the 3rd minus 14 times -2 squared plus 31 times -2 plus 6. Plug this into calculator, I got 0. Okay. The next one, p of 3. Again, 3 times 3 to the 4 minus 3, 8 times 3 to the 3rd minus 14 times 3 squared plus 31 times 3 plus 6. Calculator will also tell me that this is 0. Okay. Now that we have the given 0, we want to find all other 0 to p of x. To find all the other 0 to p of x, we'll perform the syntactic division on either one of the zeros that we are given. So let's start with c equal -2. So syntactic division. So -2 on one side, coefficient of p of x on the other, 3, -8, -14, 31, and 6. Print out the 3. 3 times -2 is -6. Add this -14, 28, 14, negative 28, 3, negative 6, 0. So p of x is written as x plus 2 times 3x to the third minus 14x squared plus 14x plus 3. Okay, so since we have two zeros that is given, that is negative 2 and negative 3, with this telling us x minus 3 is also a factor of p of x, right? This means it is also a factor of 3x to the third minus 14x squared plus 14x plus 3. So the next thing I do is to perform the syntactic division using 3x to the third minus 14x squared plus 14x plus 3. Okay, so again, I start with the syntactic division. Here's 3. And the coefficient is 3x to the third. So that's 3. Negative 14. 14 and 3. We bring down the 3. Make 9 here. Negative 5. Negative 15. Negative 1. Negative 3. That makes 0. So now I can rewrite this p of x is x plus 2 times x minus 3 times 3x squared minus 5x minus 1. I can find the other 0 for this quadratic function by using the quadratic formulas or by factor. So let's say I'll find the other 0 by factor 3x squared minus 5x minus 1. So 3x squared minus 5x minus 1 equals 0. And this don't seem to be factorable. So let's check to see whether this quadratic equation have a real 0 solution. So we check this by using the discrimination. The discrimination is b squared minus 4ac. If b squared minus 4ac greater than 0, then we have two solutions. If b squared minus 4ac less than 0, then we have 0 solution. And if b squared minus 4ac equal to 0, then we have one solution. Okay, so let's take a look at this. So let's check the discrimination. So that is negative 5 squared minus 4 times 3 times negative 1. That is 25 plus 12 equal 27. So here we have two solutions. So let's solve for the two solutions using the quadratic formula. X equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. And that is 5 plus or minus square root of 27. That's what we had earlier. Divided by 2a. So that is 2 times 3 makes 6. So that is 5 plus or minus square root of 27 divided by 6. So the 0, okay, so the 0, the p of x. So the 0 of p of x are negative 2, 3, 5 plus square root of 27 divided by 6, and 5 minus square root of 27 divided by 6. So this consistent with we have a fourth degree polynomial, so we have at most 4 solutions or 4 0. So let's say we are given the specific condition. How do we find the polynomial? So the first one said we want to find the degree 3 of polynomial with 3 0, that is negative 1, 1, and 3. This means p of x is equal to x plus 1 times x minus 1 times x minus 3. We will expand this out. That is x to the third minus 3x squared minus x plus 3. So this is the degree 3 polynomial that satisfies the given condition. However, in the next one, it's a little different. The degree 5 of coefficient and the coefficient of x to the third is 4. Okay, and here we have 4 zeros. If we want to find the degree 4, that's a typo. Okay, so and the coefficient of x to the third is 4. So start with the polynomial. P of x is equal to x minus negative 2, so plus 2, x minus 0, x minus 1, and x minus 3. Okay, so let's multiply this all out. So x times x plus 2 times x minus 1 times x minus 3. Okay, so here it satisfies the condition already before we do anything. We want the coefficient of x to the third is 4. So let's say if I go ahead and change this and say I want the coefficient of x to the third is 2. Well, if I want the coefficient of x to the third is 2, then I multiply this whole entire factor by 2, by a half. Then I will get 1/2 x to the fourth plus 2x to the third plus x squared minus 3 over 2. So then I will get the satisfied condition of coefficient of x to the third equal 2 in this case. So again, we start with finding the polynomial, then we will adjust the coefficient in the end as we wanted.